Hey guys, in the previous video we were talking about this assignment, Properties of Exponents Part 2, and we worked through several of these. We didn't get through all of them, but we picked kind of one example or a couple examples from the different sections. So if you missed that and you need something from the front page, I would go back and check that out, that video that I referred to. You can also check the answer key, check to see how you're doing on the odds, and check your notes if you need other references. We're going to go ahead and jump to the back in this video. So let's take it from 15. This is where we left off. One of the things we talked about in the last video was that in a situation like this, it may be advantageous to reduce the fraction before you take it to the power. The order that you do those in doesn't actually matter. If you take everything to the power first and then simplify later, it will result in the same answer as if you were to reduce the fraction and then take it to the exponent. However, if you think about something like 7 to the third, that's a pretty big number, or even bigger, 28 to the third, that number gets big really quickly. So if you don't want to deal with really big numbers and have to simplify a really large fraction, the better method to go here is to simplify first. So I'm just going to kind of take a look at this a piece at a time. So 7 over 28 reduces. 7 goes into both of those. So 7 goes into 7 one time. You put that 1 on top. And then 7 goes into 28 4 times. So I kind of have a 1 over 4. I don't really need that 1 in the end, but I'll leave it there for now as kind of a placeholder. Okay, now I can look at the variables. We have n's on the top and n's on the bottom. So here I'm just going to use the quotient rule. N to the 9th over n to the 4th is the same thing as n to the 9 minus 4. So whatever 9 minus 4 is, happens to be 5, is going to end up being our new exponent. So that's going to go on top there. So we have 1 n to the 5th over 4, or just n to the 5th over 4. But all of that is still raised to the third power. We haven't taken care of that third power yet. So now we're going to apply the power of a quotient. And what we know about this is that both the numerator and the denominator are going to get that power. So I need to have n to the 5th to the third, and I also need to have 4 to the third. Okay, so from here, we're just going to multiply these exponents. So this is going to be n to the 15th. 5 times 3 is 15. That's actually the power property. So that's one from yesterday, just kind of applying it in this situation. And then we're going to do the 4 to the third. So 4 to the third power is 4 times 4 times 4, and that ends up being 64. So that's our simplified version. Okay. The same is true in 16. If you try to take 18 to the 4th power and 27 to the 4th power, you're going to get some really big numbers. And you can reduce them. It'll work in the end, but it's going to make your life a little bit harder. So I would look for common factors first, and it just so happens that 9 goes into 18 twice, and it goes into 27 3 times. You can also go ahead and apply the quotient property first, because you can do like the 7 minus 3, that's n to the 4th power, and you can go from there. So that will make your life a little easier. So number 7 is asking you about that idea. So in previous video, we talked about number 13, but 13, 14, 15, and 16, they all kind of have the same idea. The idea here is that it will not give you a different answer if you apply the exponent first. So for example, on 15, if I were to do 7 to the third, n to the 9th to the third, 28th to the third, n to the 4th to the third, if I did that first, I'd get these really big powers of n, but a lot of them would cancel. I get a huge number over a huge number, but that still would end up reducing to 1 over 4. It's just a lot harder to do that. We'd still end up with the same answer. So it does not change the final answer, the order that you do it in. It doesn't matter, really, but it does make your life easier if you simplify the fraction first. And that's kind of the idea here. That's in number 17, excuse me. Okay, now number 18. This is actually a really important idea that we were going to talk about in class, but we didn't have time, and that's okay. You can kind of think about it here. We'll talk about it in class probably tomorrow as well. But what I want you to do here is I want you to use two methods to simplify the same expression so that you can see why something to the 0 power is 1, some kind of an explanation. So let's do both of those. We're going to write kind of small because we're going to need to write some stuff out here. So let's do x to the third over x to the third. And we're going to do the expanding and canceling out thing. Okay, so let me switch pencils here so this one's a little sharper. Okay, so expanding means kind of writing it in long form. So x to the third is x times x times x over x times x times x, right? So when we write it out like this, we find those common factors and we use the multiplicative inverse property to cancel. Now, it looks like everything cancels here, but what we know is that when we use that multiplicative inverse, we end up with a 1. If everything cancels, right, the number over itself is equal to 1. So this is actually equal to 1. Okay, now we're going to use that exact same expression, x to the third over x to the third, but this time we're going to solve it with a different method. We're going to solve it using the quotient property. And the quotient property says you're going to subtract the exponents. So what we're going to do is we're going to have x to the power of 3 minus 3, which is x to the power of 0. Okay, so in both cases, we started with the same expression, and we simplified using different methods. So these two, and the methods that we use were valid properties that we've talked about. So these have to be equivalent answers. X to the 0 has to equal 1. So how can we kind of think of that? How can we process that or remember that? Well, this is how I might explain this. And you can use your own words or whatever, or your own observations, but this is kind of what I'm seeing. X to the 0, the way I think about that is imagine that I had a bunch of x's that all canceled out. So I have 0 x's left. But when they all canceled, what was the number that was left over? If we're talking about multiplication and division, or the multiplicative inverse property, then the number that's left over is a 1. So when all the x's cancel and we have 0 of them left, the number that's left over is a 1. So you can write something to that effect. We want an explanation here, right? But this is going to help. So this isn't the full explanation. This is just kind of symbols showing what's happening. But from here, you can kind of extrapolate and kind of write out a sentence or two on what's happening. Okay, so the zero product property says that anything raised to the 0 power is going to be 1. The tricky part here is actually determining what is raised to the 0 power and what's not raised to the 0 power. So sometimes these are pretty easy. Like this is something raised to the 0 power, right? 500 to the 0 power is 1. And this is something to the 0 power. Y to the 0 power is 1. Again, we can think of it like maybe at one point there was a bunch of y's that canceled with a bunch of other y's, and there's 0 left, but when they all canceled, we had a 1 left over. Okay, so this idea again. Okay, now 21, it starts to get a little different. We have to think to ourselves, what is that power of the 13 and what is the power of the q? So in this case, the 13 or the negative 13 is not actually being raised to the 0 power. Only the q is. Actually, the power on that negative 13 is just a 1. So this part only becomes a 1. Just the part that's raised to the 0 power. So this is negative 13, or negative 13 to the 1 power, times 1. Okay, so this piece turns into a 1. So our final answer isn't 1 because the whole thing wasn't raised to the 0 power. All right, now if you take a look at 22 and 23, they actually look really similar. But take a minute to consider what the differences are. Obviously this has parentheses, and this one doesn't. And the parentheses create a grouping. So in problem number 22, the 20 is not being raised to the x power. Very similarly, it's not being raised to the 0 power. Sorry, let me say that again. The 20 is not being raised to the 0 power. Only the x is. So I can write this as 20 to the 1 power, that's just 20, times x to the 0 power. So this is actually going to stay at 20. Only this piece changes. That becomes a 1. So this expression becomes 20 times 1, which is just 20. Okay, now in 23, a little bit different here, we have a grouping symbol. And so here, the 20 is being raised to the 0 power, and the x is being raised to the 0 power. And so we can just say that this is just some number, some quantity here, raised to the 0 power, so this thing is going to be 1. Now you can kind of do it, sorry, that kind of looks like a 7. I'm trying to make my 1s look like 1s, so we don't get them confused with other numbers. What we could do is we could apply a property called the power of a product. So what we could say is, okay, the 20 gets the power of 0, and the x gets the power of 0, right? But again, this is just 1, and this is just 1, so I end up with 1 times 1, which is still 1. So whether you want to try to kind of break this up into pieces and apply this 0 to each of these factors, or whether you want to just look at it as one thing raised to the 0 power, one product raised to the 0 power, either way you're going to get 1. And the same is actually true for number 24. So you can think of this as, you can kind of multiply these exponents using the power of a product. So 0 times 1 is 0, so I have 4 to the 0. 0 times 2 is 0, so I have x to the 0. But both of these are 1. Anything to the 0 power is 1, so this becomes a 1, and this becomes a 1. So this is just 1 times 1, which is 1. Right? So again, if you split it up into pieces and have everything as a 0 power, they're all going to be 1s, or you can kind of keep it as this product and think of it as one piece, one product raised to the 0 power, which is just going to give you a 1. So you don't have to do a whole lot of work here. You just figure out what's being raised to the 0 power. If it's everything, cool, then the answer is 1. If it's part of it, then that piece will become 1, and you'll have the rest of it. Okay, so 25, we kind of talked about this already, and again, you're going to use your own words to describe what's happening. But the main difference here was which pieces were being raised to the 0 power. In here, only the x was being raised to the 0 power, and so that's the piece that turns into a 1. Here, everything was raised to the 0 power, which means that whole chunk, 20x to the 0, turns into a 1. So not everything is raised to the 0 power in here, and it has to do with the parentheses, changing the order of operations. So you can write something to that effect in number 25 in your own words, but that's the idea. All right, now 26 looks like a beast. It looks really, really brutal. And there's a point to making it look like this, because if you really know the properties, then this is actually a very, very easy problem. The 0 exponent property says anything raised to the 0 power is 1. And so what we have here is something raised to the 0 power. So the answer to this is 1. It's just 1. Now you could try to apply other properties here, like you could say, okay, well, each of these pieces needs to get a power of 0. That's like the power of a product and the power of a quotient. So you could write this as, okay, it's 17 to the 0 times x to the 9th to the 0 times y to the 24th to the 0, right? Like you could do all that, but 17 to the 0 is just 1. And x to the 9th to the 0, if you multiply these, then you're going to get x to the 0, which is 1. And if you multiply these, 24 times 0, you get 0. So y to the 0 power is also 1. So these all end up turning into 1s anyway. So you don't have to go through that step. One of the things we're going to talk about tomorrow is kind of creating an order of operations for dealing with properties of exponents. There actually really isn't one, in the sense that it'll give you a different answer or you'll be wrong, but there is kind of an order of operations in the sense that there's an easier way to go about it. So we want to talk about strategies, right? If we were to apply the power of a product or the power of a quotient property here, it would take a lot longer to get to the same answer, versus if we just looked at the 0 exponent property first and just considered that this was one big quotient raised to the 0 power. So we're going to strategize on how to make our lives easier when we're dealing with these properties. But here, kind of the moral of the story is there's usually an easier way to go about it. And in this case, it's easy to just say this is 1. Something to the 0 is 1. All right, I hope that helped. Again, if you're stuck, I would always go back to your notes as well. Look at the examples that we did in class. Again, the videos that are going to be helpful, I've got some other videos posted on these properties, the basics of these properties, so you can check those out. That's in the post before this assignment. And if you're still stuck after that, I would just shoot me an email. Let me know what you're struggling on, and we can figure out a time to meet and talk about that. Or you can swing by in the morning if you have time, and we can maybe talk about it briefly. Okay, hope that helps, guys.